FAKUMA 2021. It's all about injection moulding. 1,500 exhibitors. We're on a FANUC stand. Paul, over to you.
Well, we've been here about 2 days now looking at this, the technology, and how FANUC are bringing all aspects of their products together here with automation, the machines, the software. But specifically what we're going to talk about in this video is things like power consumption, cooling of parts, and this is a 220. So what does that mean, Colin?
220 tonnes. It's the biggest in the SIB, which is the latest generation of robo-shop machines, up to 220 at the moment, but they're going 450 next year in 2022.
Okay, now I suppose that varies then in the application, doesn't it? Depends on what you're doing as to the tonnage that you need.
Number of components in that mould, materials, everything like that. Application specific, as we like to say.
And just briefly, this is where the material goes in, isn't it?
Yep.
In this hopper, and then it's heated up, is
Correct.
it? And then it goes into into what you call the screw.
Correct.
And then it goes into the mould tool, is where the mould is created. But throughout that whole process, it's heated to whatever temperature.
It is, but there's a slight caveat, because different materials, like silicon, it's going the other way. It's cooling, then heated in the mould. But generally, materials in here, plastics, and you can see here, and it can also showcase how great these controls are. So I can see the temperature there, 50 degrees in the hopper. That's drying the pellets, and then running through the screw, 225, 230, 235, and then into the mould.
And the gentleman was saying that this particular part is about heated up to about 250, isn't it,
Yep.
I believe?
Yep.
Now, what happens after you've heated it, after it's been moulded? You need to cool it before
Correct.
it's ejected out the back. So how does that work?
Different options depending on the temperature, up to about 160 degrees water cooled.
So up to 160, you do it
Yep.
with water, yeah?
Yep. If you're going up to about 250, oil cooled. So, but again, you need to be careful with that, because if something does break, I mean, it very rarely happens, but can do.
And then when you go beyond that, then I suppose if you're really into a very special material.
Yeah, just take the step back. Up to 250, looking at materials like your peaks, but above that, get in contact with the suppliers. I need a specialist material over 250, electric cooled.
So you then cool it electrically.
Yep.
Just, I suppose, parts like then you'd be talking about parts that might be needed in the electrical environment that need to be very durable and withstand heats themselves.
Exactly, that's exactly it, yeah.
Okay, all right, let's have a walk around the back and just see the part that this is actually producing. Another brilliant example, really, of FANUC working with an integrator, because this isn't their robot solution here, is it?
Correct. Slightly different application, because it's in this one, it's only sort of almost picking and placing. Very simple application. It's only a 2-axis robot. So into the mould, taking the part out and dropping it on the conveyor. So that's why they're only using this robot, as opposed to one of their 6-axis robots.
So this is all about quantities again, quantities of the same product being mass produced.
Yep.
But in an automated environment.
Reliable, high precision, repeatable. That's key to what these guys do at FANUC. And it's all in-house. So you've got your robo shop, your robo job, your robo cut, whatever it might be, and your software as well. It's all manufactured in-house, so you get complete continuity, essentially.